do another step of it. Okay, and by that I mean that the making the Hessian border matrix. Okay, so we know that, let's recall, we know that the Hessian border matrix for m is equal to 1 and n is equal to 2, it will be a 3 cross 3 matrix. Okay, and this 3 we get from m plus n. Okay, cross m plus n. So m plus n is equal to 1 plus 2 is equal to 3. Okay, so this will be a 3 cross 3 matrix, and in this 3 cross 3 matrix, the first point it will be 0. The second point will be differential of h with respect to x1. Okay, and the second point will be, the third point, sorry, it will be differential of h with respect to x2. Okay, in the column it will also be the same as in the row. Okay, now we need to find this point, this point, this point, and this point. So for those we have the second differential of f with respect to x1 square minus lambda into second differential of f with respect to x1. It means that double differential with respect to x1, and in this point we have the double differential of f, the function, okay, with respect to first x2 and then with respect to x1. Okay, and the minus lambda into double differential of f with respect to with respect to same dx2 and then dx1. Okay, now here, okay, and we know that in the corner, the diagonals, we have the differential with respect to the same. So I will first write this one, and it is like differential, the second variable is x2, so it is x2 square minus lambda into d square h with respect to x2 square. It means that first making the double differential with respect to f and then double differential with respect to x2. First differential with respect to x2 for f, the function, and then minus lambda into the double differential of h with respect to x2. Okay, and here it will reciprocate this one. Okay, so here it will have, here the first differential with respect to x2 and the other one is, second one is x1, but here it will be, the first one will be x1 and the second one will be x2 minus lambda into h, and second one x2 and the first one with respect to x1. So this will be the matrix m plus n into m plus n. Okay, we have like 3 cross 3 matrix. So let's find the each one of the point over here. Okay, so the matrix is equal to, okay, let's write it over here. This is 3 cross 3 matrix. Okay, so the first one is 0. Okay, now the partial differential of h with respect to x1 is equal to the partial differential, now h over here is equal to x1 plus 5x2 minus 7. Okay, so we get differential of x1 with respect to x1, it will get us a value of 1 plus 5 into differential of x2 with respect to x1, it will get us a value of 0 minus, this is constant, so it will yield a 0 value. So differential of h with respect to x1 is equal to 1. Okay, so here we can put the value of 1, and here it is also 1. Okay, because this one and this one will be equal. Okay, now calculating this one and this one is equal to differential of h with respect to x2. So we can write it as x1 plus 5x2 minus 7. Okay, now the partial differential of x1 with respect to x2, it will give us a value of 0 plus 5 into d by dx2 of x2 minus 0. Okay, it will give this is 0, so we can write as 5 into d by dx2 of x2 is equal to 1. Okay, so we will get a value of 5 over here. So the partial differential of h with respect to x2 is equal to 5. So this is 5 and this is also 5. Okay, now we need to find this one, this one, this one, and this one. Okay, now we know that the diagonal element, okay, this one and this one, this will be the double derivative with respect to x1, and this will be the double derivative of the function with respect to x2. Okay, so let's find this one. Okay, so this point actually, okay, this point, it is equal to d square f with respect to dx1. It means that making the first derivative with x1 and also the second derivative with respect to x1 minus lambda into the first derivative of h with respect to x1 and second derivative of h also with respect to x1. So let's do it. We have, okay, so d by dx1 of f, okay, it is already, we have found it, because when we want to find the equations for it, okay, we calculate it. So let's find it from there. Actually we can just calculate it again. Okay, so if the function is equal to, from the question, the function is, let me have this is the function. Okay, 6x1 square plus 5x2 square. Okay, this is the function. So we can write it as 6x1 square plus 5x2 square. Okay, so now it is with respect to x1, so this x2 will yield 0, and this x1 will give us a value of 6 into 2x1 into 1. Okay, so it will give us a value of 12x1. Okay, so partial derivative of f with respect to x1 is equal to 12x1. Now the second derivative, taking the second derivative with respect to x1, it will get us, because it can also be written as okay, so this one is already found over here. Okay, so we can take the derivative as 12 into d by dx of x1 is equal to 1, so it will get a value of 12. Okay, now we also have this lambda and this one, so d by dx1 of h, this is already found. Okay, this is d by dx1 of h. Okay, and we get a value of 1. Okay, so d square will get us a value of d by dx1 of 1 is equal to 0. So we can get, putting the values over here, we get 12 minus lambda into 0, so we get a value of 12 over here. So here we can put a value of 12. Okay, so now we need to find this value, and then we will come to this one. Okay, Now the we need to find this one, okay, the second order derivative of f with respect to x2 and the second derivative of h with respect to x2, and this is the diagonal last element. Okay, now similar to this one, we first find the first order derivative of f with respect to x2. So we get the function is 6x1 square plus 5x2 square. Okay, now the x1 will get a value of 0 and we can get a value of 10x2 over here. Okay, so the first order derivative of f with respect to x2 is 10x2. Now if we again derive this one with respect to x2, okay, then we get t square f by tx2 square is equal to d by tx2 of 10x2. Okay, so we get a value of 10. Okay, now we get a value of 10 over here, but we also have a second part, which is the second order derivative of h with respect to the x2. Okay, we need to find that also. Now the second order derivative of h with respect to x2, it is equal to the first order derivative of h with respect to x2. Okay, this is to be found first, and then when we find this, we need to derive it again with respect to x2. Okay, we first need to find the first order derivative. So the first order derivative of h with respect to x2, we already found it in the first part of the problem. Okay, in the matrix actually. Here when we were making this is the first order derivative. This is the first order derivative of h with respect to x1. This is the first order derivative of h with respect to x2. So this is the first order derivative already found. Okay, we can this is already found, but we can find it again if this is just for you. Okay, h is equal to the x1 plus 5x2 minus 7. Okay, this is the constraint. Okay, now regarding x2, okay, making the derivative of it, we get the derivative of x1 will become 0 plus 5 into 1 minus 0, so it is equal to 5. Okay, the same that we just saw in making the matrix. Okay, now again deriving it, okay, with respect to x2, it will get us a value of 0. Okay, now d square f by dx2 square minus lambda into d square h divided by dx2 square is equal to, this one part gave us a value of 10. Okay, minus lambda into, and this one part is equal to 0, so it will give us a value of 10. So the third diagonal value over here, this equal to 10. Now we need to find this one because it requires the derivative, the first derivative regarding x2 and then x1, and here the first derivative with respect to x1 and then x2. So it requires derivative with respect to both. Okay, now this one value is equal to the second order derivative, okay, with respect to x1 and the first order derivative with respect to x2 minus lambda into the first order derivative with respect to x2 and second order derivative with respect to x1. Okay, now remember this, here is the catch. Okay, if this is x1 and x2, okay, if in f the function and h the constraint, if we have x1 x2 term over here, then this will yield some value. But if x1 x2 is not happening over there, okay, we don't have a term which has these two variables multiplied, then it yields a value of 0. In short, like, I will give an example, okay. For example, we have a function f of x is equal to x1 plus x1 square plus x2 square plus 2x1 x2. Now here we have x1 x2 over here. So if the case is like this, then this will yield some value. But if we have f of x is equal to x1 square plus 2x2 square, okay, we don't have any x2 x1 and 2x2 over here, then this thing actually it will become 0. It will yield a value of 0. This is the shortest thing. You don't need to calculate this, okay. So if we see the function over here in the question, actually f of x1 x2, it is equal to 6x1 square plus 5x2 square. We don't have any x1 into x2 over here, so this thing will yield a value of 0 minus lambda into, now h of x1 x2, the constraint, it is equal to x1 plus 5x2 minus 7, okay. This also doesn't have any x1 into x2, so it will also be 0, okay. So we get a value of 0 over here. Similarly, the d square f by dx2 dx1 minus lambda into d square h by, it means the only difference is that the first order derivative is regarding x2 and the second order derivative is regarding x1, and here the first order derivative is for x1 and the second order derivative is for x2, okay. This is the only difference, and it will also yield a value of 0, okay. Now putting the values in the matrix, okay. So here it is the matrix, and here this will be equal to 0 and this will be equal to 0. Now we have a Hessian border matrix H of B, and these are the values for it, okay. Now when we have values of it, okay, now we find the matrix of the determinant of it, okay. So determinant of this is 0 1 5 1 12 0 5 0 and 10, okay, and it gives us a value of minus 310, okay. Now this determinant is negative, okay, so it is minima, okay. And if we put it into z, okay, the function of it, we get 6x1 square plus 5x2 square. So 6 into x1 was equal to 0.225 whole square plus 5 into 1.355 whole square. It gets a value of about 9.48, okay, and this is the best value for it, and it is the minimum best, okay, optimized at this value for x1 is equal to 0.225 and x2 is equal to 1.355. Let me know if you don't know how to make the determinant in 3 cross 3, okay. In 2 cross 2 it is simple, but in 3 cross 3 it is a bit of process, so let me know, okay. Also doing it another way I will show in the next video, how to know that it is maxima or minima, okay, just that part, not all the parts, just that part. Okay. So now moving to 3 variables and 1 constraint, 3n and 1m problems. Variables, m means constraints, so 1 constraint and 3 variables. It means that x is equal to x1, x2 and x3, okay, and g of x is equal to h of x1 to x3. This is the constraint. And f of x1, x2, x3, the function is equal to x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3. Okay, so this is the function, and the constraint subject to the constraint is equal to x1 plus x2 plus x3 is equal to 7. So this can be termed as h of x1, x2, x3. Okay, this is the constraint. Now we need to first convert it into the Lagrange function. So L is equal to x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3 minus lambda into x1 plus x2 plus x3. This will transfer into this, okay, and it will be equal to 0. We will write it into equal to 0 form. Okay, so this is the Lagrange function. Now we have 3 variables and 1 constraint. So first of all, we need to find the stationary points z0 or x steric. Okay, for stationary points we need to find the single derivative of L with respect to x1 and equate it to 0, second derivative of L with respect to x2 and equate it to 0, and the partial derivative of L with respect to x3 and equate it to 0. And we have 1 constraint, so only lambda is here, so we need to find the partial derivative of L with respect to lambda and equate it to 0. Okay, so we need to do these all of 4. It will give us a set of equations, and we need to explore or analyze or solve those equations for x1, x2, x3 and lambda to find all these 4 values. Okay, so first the partial derivative of L with respect to x1, it is equal to partial derivative of x1. This is the L function, x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3 minus lambda into x1 plus x2 plus x3 minus 7. Okay, now to make it easier for you, actually, okay, if here it is x1 and we want to differentiate or make partial differential of x2, x3 or any other variable which is not x1, then it is equal to 0. Only x1 will give us some value. Okay, this is the first rule. Okay, so here only this part will give us some value. This will be 0, this will be 0. Here we have x1, so this will give us some value. This will be 0 and this will be 0. So if we make a differential of x1 square with respect to x1, it will give us a value of 2x1. Okay, minus, if we will ignore these two because it will give us 0 values. Okay, so minus 10x1 will give us minus 10 into 1. Okay, minus lambda is here as constant, okay, into differential of x1 will give us a value of 1 and all other will be 0. So we can write it as so now equated it to 0. So 2x1 minus 10 minus lambda is equal to 0. This is the first equation that we get, okay. Now after this we need to do this part, okay. Now partial differential with respect to x2. So same rule will apply, okay. Only the variables x2 will give us some value while all other will be 0, okay, and lambda is constant over here, okay. Lambda will be variable only when we do the partial differential with respect to lambda, okay. So here this will give us 0, this will give us 0, 0 and 0, so only these two will give us some value, okay. So x square will give us 2x2, x2 square will give us 2x2 minus 6x2 will give us minus 6, okay, minus lambda into x1 will give us 0, x2 will give us 1, x3 will give us 0 and minus 7 will also give us 0, so it will be minus lambda into 1, okay. This is the partial differential of L with respect to x2. Now equated it to 0, so we get 2x2 minus 6 minus lambda is equal to 0, and this is the second equation that we get over here, okay. Now doing the third one, because we have three variables, so we differentiate or we make the partial differential of L, the Lagrangian function, with respect to x1, x2 and x3 respectively, okay, because we have three variables over here. So making the partial differential with respect to x3, so partial differential with respect to x3 for L is equal to, okay, here taking this, x1 will give us value of 0, x2 will give us a value of 0, x3 on the other hand will give us a value of, this is x3 square, so it will give us 2x3, so it is equal to 2x3, okay. This will give us a value of 0, 0 because x1 and x2 are here, x3 is over here, so it will give us minus 4 into 1, okay, minus lambda into x1, this will be 0, 0, this will be 1 and this will be 0, so lambda into 1, so it will give us 2x3 minus 4 minus lambda is equal to 0, okay, and this is the third equation that we get. Now we make the partial differential of L with respect to lambda, okay. Now d by d lambda of L is equal to d by d lambda of the function, main function, okay, minus lambda into x1 plus x2 plus x3 minus 7, okay. Now all these variables are not in lambda form, okay, we don't have any lambda over here, so it will give us a straight up 0, this all of these will give us 0, okay. Now here lambda is a variable over here and x1 plus x2 plus x3 minus 7, this is the constant, so we will take the constant in front and will make the differential of the main variable, okay. So we will get over here is this will give us a value of 1, so we will get x1 plus x2 plus x3 minus 7 is equal to 0, and this is the fourth equation that we get. Now we will solve all these four equations for x1, x2, x3 and lambda. We will find the value of these four and then we will go to the next step. Let me write all the equations on this page. Okay, so I see all the equations straight in front of me so that we can actually solve it. Equation 1 is 2x1 minus 1 minus lambda is equal to 0, or 2x1 minus 10 actually. 2x1 minus 10 minus lambda is equal to 0. This is first. The second one is 2x2 minus 6 minus lambda. 2x2 minus 6 minus lambda is equal to 0. This is the second equation. Okay, now the third equation is 2x3 minus 4 minus lambda. 2x3 minus 4 minus lambda is equal to 0, and this is the third equation. The fourth equation is the constraint actually, x1 plus x2 plus x3 minus 7 is equal to 0. This is the fourth one. Okay, so now we will solve this set of equations for x1, x2, x3 and lambda. We need to find all these four values. So first of all, we don't have any equation in which we have like x1 and x2 together, or x1, x2, x3 together, except for 4. Okay, so first we solve it for lambda. Okay, so to solve it for lambda, we add 1 and 2. Okay, let's add 1 and 2. We get 2x1 minus 10 minus lambda is equal to 0, and 2x2 minus 6 minus lambda is equal to 0. Sorry, no, don't add it, but subtract 2 from 1. Subtract 2 from 1. Okay, we get subtract, it is minus, it is plus, and it is plus. Minus and plus will cancel each other out. Okay, we here will get minus 4, and here we will get 2x1 minus 2x2 minus 4 is equal to 0. This is the fifth that we get over here. Okay, now if we multiply equation 4 by 2, we get 2x1 plus 2x2 plus 2x3 minus 14 is equal to 0. Okay, now we have over here 2x1 minus 2x2 plus 0x3 minus 4 is equal to 0. So what we can do is we can just add them, and we can get 4x1 plus 2x3 minus 18 is equal to 0. So let's solve it for x1. How can we get the values for x1, x2 and x3? Let's think about it. Now let's add let's subtract actually equation 3 from 2. Equation 2, we get 2x2 minus x minus lambda is equal to 0, and 2x3 minus 4 minus lambda is equal to 0. So we get minus, plus and plus. Okay, so minus 2, and it will get 2x2 minus 2x3 minus 2 is equal to 0. Let's name it as equation 6 that we get over here. Now we have 2x1 and 2x3. x2 and x3 are available here. x1 and x2 are available over here. So we can actually add them to find, add 5 and 6 actually, and let's see what happens. 2x1 minus 2x2 minus 4 is equal to 0. 2x2 minus 2x3 minus 2 is equal to 0. Okay, so we get 2x1 minus 2x3 minus 6 is equal to 0. Let's name it equation 7. Now here we have 2x1 and 2x2 and a number. Here we have 2x1, 2x3 and a number, but we need 2x2 over here. We don't need 2x3, we need 2x2. So how can we get 2x2 over here? Let's think about it. Okay, my bad actually. So actually we can do it in some other way. Let me show you like how we can do it. I actually took a break from doing the question and did it on rough and then came up with the idea. So yeah, we can actually, we have like 2x1 minus 10 minus lambda is equal to 0. This is 1, so we can write it as 2x1 is equal to 10 plus lambda. So x1 is equal to 10 by 2 plus lambda by 2. Okay, it is equal to 5 plus lambda by 2, and it is equal to x1. Now we have the value of x1 over here, but lambda is unknown, so we need to find lambda. Okay, we will term it as 1. Okay, now 2x2 minus 6 minus lambda is equal to 0. Similarly, 2x2 is equal to 6 plus lambda, and x2 is equal to 6 by 2 is equal to 3 plus lambda by 2. This is second one that we do, and we have now x2 value, but just we need to put lambda over here. Okay, and the third one is 2x3 minus 4 minus lambda is equal to 0. Imply this 2x3 is equal to 4 plus lambda, and x3 is equal to 4 by 2 will get us 2 plus 1 over 2 lambda or lambda by 2. Okay, now this is the value of x3. Okay, now we put all these values into this equation, which is the fourth one. X1 plus x2 plus x3 minus 7 is equal to 0 implies that x1 is equal to 5 plus lambda by 2 plus x2 is equal to 3 plus lambda by 2 and x3 is equal to 2 plus lambda by 2. Okay, minus 7 is equal to 0. So we put this 7, transfer it to the other side. So 5 plus lambda by 2 plus 3 plus lambda by 2 plus 2 plus lambda by 2 is equal to 7. Okay, now 5 plus 3 is equal to 8. 8 plus 2 is equal to 10. Okay, so 5 plus 3 are 8 and 8 plus 2 are 10. So lambda by 2 plus lambda by 2 plus lambda by 2 plus 10 is equal to 7. So this is 3 into lambda by 2 is equal to 7 minus 10, implies that 3 into lambda by 2 is equal to minus 3. This is multiply over here. When it comes to this direction, the right hand side, it will divide. So lambda by 2 is equal to minus 3 divided by 3 implies that lambda is equal to 2 into minus 3 by 3 is equal to minus 2. So this is the value of lambda that we found over here. Okay, now that we have the value of lambda, just put lambda is equal to minus 2 and 1, 2 and 3 respectively. Okay, so x1 is equal to 5 plus lambda by 2 is equal to 5 plus minus 2 by 2, which is equal to 5 minus 1 is equal to 4. So x1 is equal to 4, or we can say that yes, exactly, we get 4 over here. Similarly, x2 is equal to 3 plus minus 2 by 2 is equal to 3 minus 1 is equal to 2, and x3 is equal to 2 plus 1 over 2 lambda implies that 2 plus 1 over 2 into minus 2. This will become 2 minus 2 and it will be 0. So x3 is equal to 0. So we have found now all these values. Sorry, this one is 2 minus 1. 2 and 2 will get cancelled, so it will be minus 1. 2 minus 1 is equal to 1. x3 is equal to 1. Okay, so now we will see that the x steric or z0 is equal to 4, 2 and 1. Is this maxima or minima for the function? Okay, and this will be done with the bordered Hessian matrix. Okay, now doing the procedure, starting the procedure for the bordered Hessian matrix. Okay, we know that the bordered Hessian matrix for the it will be equal to m plus n. So m over here is 1 and n is 3. So it will be a 4 cross 4 matrix. Okay, and it will have 16 elements. So the first element is 0, we know that. Second element is the partial differential of h actually, which is the we say constraint. Okay, and the third is the partial differential of h with respect to x3. Similarly, it will replicate over here in the same fashion. Okay, d by dx1 of h, d by dx2 of h, and d by dx3 of h. Okay, now in this one, as this is the diagonal element, so it will be d square f by dx1 square minus lambda into d square h by dx1 square. It means that there's double derivative of f with respect to x1 and the double derivative of h with respect to x1. Okay, now for this one, actually, okay, for this one it will be the partial derivative of f with respect to x2 and the second order derivative with respect to x1 minus lambda into the partial derivative of h with respect to x2 and the second one with respect to x1, and the next one is the partial derivative of f with respect to x1 and x3 minus lambda into partial derivative of h with respect to x3 and the second order with respect to x1. Okay, similarly over here we will find the partial derivative of f with respect to, this is x2, so it means that the first one will be x1 and the second one will be of x2, so x1 and the second one is x2 minus lambda into d square f, second derivative x2 and the first one is x1, and this is the diagonal element, so it will be d square of f with respect to x2 square minus lambda into d square of f with respect to x2 square, and here it will be the first partial derivative will be with respect to x3, but the second one will be with respect to x2 minus lambda into the first order derivative with respect to x3 and the second order derivative with respect to x2. Okay, and here it will be the first order derivative of f with respect to x1, but the second order derivative will be with respect to x3 because this is the x3 row. Okay, minus lambda into the first order derivative of h with respect to x1 and the second order with respect to x3. Now here it is the first order derivative with respect to x2 and the second order derivative with respect to x3 minus lambda into the first order derivative of h with respect to x3 and x2 and second order derivative with respect to x3, and this is the corner, the diagonal element, so it is the first order derivative of f with respect to x3 and the second also with respect to x3, so we can write it that x3 square minus lambda into the first order derivative of h with respect to x3 and x2 the second order with also x3, so we can write x3 square. This is the for this element actually. Okay, don't be confused with it, I write it outside because there was no space over here. Okay, so now we need to find this matrix. Okay, I will find the matrix in the next video. Okay, so let's find the bordered Hessian matrix. Okay, HRP, as it is 4 by 4, so here the first item will be 0. Okay, this element, second element, this will be the differential of h which is constrained with respect to x1, so the constraint is x1 plus x2 plus x3 minus 7. Let me confirm it. Yes, So here we have x1, x2, x3 and 7. Differential of this will be 0, 0, 0 and this will be 1. So we get 1 over here. So d by dx1 of h is equal to 1. So we write 1 over here. Now for this element, this is d by dx2 of h. Okay, so partial differential of h with respect to x2 is equal to d by dx2 of this x1 plus x2 plus x3 minus 7. So here differential for x1 with respect to x2 will yield 0, this will yield 1, 0 and 0, so it is also equal to 1. So it is also 1. For this we have the differential of h with respect to x3. Okay, so it will also yield 1. So it is 1. So it is 1, 1 and 1, because this will be equal to this, this will be equal to this and this will be equal to this. Okay, now we need to find this one. Okay, so this one is the diagonal one. Okay, this is the x1 column and this is the x1 row. So it means that the first differential will be according to x1 and the second will also be according to x1. Okay, for this the first differential will be with respect to x2, this is the x2 column, and the second order derivative differential will be regarding x1. Similarly for this is the third x3 column, so here the first order derivative will be with respect to x3 and the second order derivative will be with respect to x1. This is the x2 row, this is the x3, sorry, this is the x2 row, let me write it in front of it, and this is the x3 row. Okay, so now you can relate it. First order derivative with respect to x1, second with respect to x2, first with x1, second with x3, and so on. Okay, for all these. So now we need to find this element. So this is x1 column and x1 row. It means that we need to find both order derivatives with respect to x1. So we need to find this thing. Both order derivatives are with respect to x1. Okay, so function is x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3. Minus 10 minus 6 minus 4 minus 10 x1 minus 6 x2 minus 4x3. This is the function. Okay, so second order derivative with respect to x1 and also the first order derivative with respect to x1. So first order derivative d by dx1, it will give us 2x1 minus 10 into x1 will be 10 into 1. Okay, so it will give us 2x1 minus 10, and the second order derivative with respect to x1 will give us, this is the first order derivative, and the second order derivative is equal to the derivative of the first order derivative. Okay, this one is already found, which is 2x1 minus 10. So taking the derivative of it will give us the second order derivative with respect to x1. So okay, so it will give us 2 into 1 2 minus 10 into d by dx of 10 is equal to 0. So 2 minus 0 is equal to 2. So this will give us 2. I'm not actually writing it the h over here because it will give us a 0. Okay, how it will give us 0? Let's find it. This is the d by dx1 of h. This one is found to be 1. This is 1, okay, and this is equal to d by dx1 of h, okay. Now when we make the derivative of again, then d by dx1 of 1 is equal to 0, so it will give us automatically a 0 value. So 2 minus lambda into 0 will give us a 0, so 2 minus 0 is equal to 2, so I wrote 2 over here directly. There is no need to do the h1, okay. Now this one element, this means that the first derivative will be with respect to x2 and the second one with respect to x1. So now finding the derivative of f with respect to x2. So if we found the derivative of the function with respect to x2, we get and one other thing, one important note is that this is x2 and this is x1, okay. This will only yield a value if we have x1 x2 term over here, and we see that in the function, the whole function, there is no x1 x2. In the whole h there is no x1 x2, so these are automatically 0, so we can write this as 0 and 0. The all other than the diagonal, okay, except the first, these are zeros, okay. This is not diagonal, so it is 0. This is diagonal, this is diagonal, this is not diagonal, so it is 0. So we need to find this diagonal and this diagonal, okay. Now finding this diagonal is the first derivative with x2 and second derivative also with respect to x2, okay. So now d by dx2 of f is equal to d by dx2 of the function is x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3, okay. This is x2, so this will yield 0, this 0 0 and 0. Only x2 square and minus 6x2 will yield some value, and how much value it will yield? It will yield 2x2 minus 6. This will be the first order derivative. Now derivating it again with respect to x2 will get us okay 2 into 1 minus 0 will give us a 2, okay. Now the derivative, second order derivative of h with respect to x2 will be, so the first order derivative okay, we need to find first the first order derivative, okay. So d by dx2 of h is equal to d by dx2 of x1 plus x2 plus x3 minus 7, okay. Only x2 will yield 1 and all others will be 0, so it will be equal to 1. D by dx2 of h is equal to 1. Now again making the derivative, it will equal to 0, okay. So d square f by dx2 square minus lambda into d square h divided by dx2 square, it will yield this is 2 minus lambda into 0, so it will be 2, so we can write it as 2 over here, okay. Now taking both derivatives, both order derivatives with respect to x3, we get actually okay, we get let me calculate d square f dx3 square minus lambda into d square f with x3 square, okay. Sorry, this is h, okay. So first finding the double order derivative of the function with respect to x3. Okay, so for this we need to find the first order derivative first. So d by dx3 of f is equal to d by dx3 of the function x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3. Okay, only here it will yield some value and this one will yield some value, 0 0 0 and 0. Okay, so it will be equal to 0 plus 0 plus 2 into x3, okay, minus 0 minus 0 minus 4 into 1, so it will yield 2x3 minus 4. This is the first order derivative of f with respect to x3. Now derivating it again, we get the d square f with respect to is equal to d by dx3 of this one, 2x3 minus 4. Okay, now this is x3 and this is x3, so it will give us a value of 2 into 1 minus, this is constant, so it will become 0, so it will become 2. So d square f by dx3 square is equal to 2, but we still have this one to find out. Now d square h by dx3 square, it's still to be known, so we need to find first the first order derivative of h, okay, which is equal to 1, by the way, because we already found it. This is the d by dx3 of h, this is also d by d3 of dx3 of h. Okay, so it has yield a value of 1. First order derivative of h with respect to x3 is 1. Okay, and when we get the second order derivative of the same, so it will be equal to the derivative of the 1, which is equal to 0. Okay, so 2 minus lambda into 0 is equal to 2. So writing the value over here as 2. Now we have 4 by 4 matrix, which is the Hessian border matrix. Okay, now here is the catch, okay, to how to find the maxima and minima. Okay, we know that x steric, the stationary points, are maxima if starting from the principal minor of the order 2m plus 1. Okay, the last principal minor of the Hessian border matrix form alternating sign starting with minus m raised to the power m plus n, and it is minima if starting with principal minor of order 2m plus 1, the last n minus m principal minor has sign of minus m minus 1 raised to power m. So let us do this thing, okay, and see. Okay, now the matrix is, let me write the found matrix: 0 1 1 1 1 1 1 2 2 2 0 0 0 0 0 0. Okay, this is the matrix. Now it says that starting from the principal minor is actually the determinant of it. Okay, so starting from principal minor of order 2m plus 1, now the order to start is 2m plus 1. Now m is the number of constraints, implies that 2 into 1 plus 1, m is equal to 1 over here. Okay, we have only one constraint, so it means that we start from 3 cross 3. Okay, 3 cross 3. Okay, so now we need to find the determinant 3, d3. Okay, d3 is the determinant of 0 1 1 1 2 0 and 1 0 2. Okay, this is the d3. We need to find the determinant of it and see the value of it, if it is less than 0 or greater than 0, and then we want to find the determinant of 4 by 4. Okay, and let's see if it gives us an alternating signs or it gives us some negative or positive signs. Okay, so we started from 2 into m plus 1, 2m plus 1, which is equal to 3. So we started from 3 cross 3 matrix and found the determinant of it. Determinant of it is equal to minus 4, okay, which is less than 0 and has negative sign, okay. And now, and the last one is n minus m, which is equal to 4 by 4, okay. So the 4 by 4 matrix also has the minus 12 is equal to, determinant is equal to minus 12, which is also less than 0, okay. And it says that if it is maxima, the last one will have like alternating sign, okay, and starting from minus 1 raised to power m plus n. So minus 1 raised to the power m plus n is equal to, m plus n is equal to 1 plus 2 is equal to negative, okay. And minus 1 raised to the power m is also negative, okay. So it does not have an alternating sign, it doesn't have any alternating sign, okay. This is negative and this is also negative, okay. So it means that this is the minima of it, okay. This is the minima of the function, because the last one, the first one has minus 4 sign, negative sign, and the last one d4 has also negative sign, okay. And the sign is minus 1 raised to power m. So minus 1 raised to power m gives us minus 1 raised to power 1 is equal to minus. So the first starting sign is negative and the second one is also negative. So this is the minimum position, okay. We can find the z value for it by putting the x1 and x2 values into it, okay. You can just calculate it by yourself. This is the function. Let me write it down for you. Where is the function? Yeah, this. Okay, the function is z is equal to x1 square plus x2 square plus x3 square minus 10x1 minus 6x2 minus 4x3. Now x1 is equal to 4, x2 is equal to 2 and x3 is equal to 1, okay. Putting the values, yes, 4, 2 and 1, these are the values. So we get 4 square is equal to 16 plus x2 square 4 plus x3 square 1 minus 10 into x1, 10 into 4 minus 6 into 2 minus 4 into 1. So it gives us 16 plus 4, 20, 21 minus 40, 21 minus 40 minus 12 minus 4. So it will give us minus 16 minus 56. So 21 minus 56, it will give us minus 35. So z is equal to minus 35 and it is the minimum value for it, the minima. Thank you.